Hi, we've now come to lecture 8, which involves the upper level vector analysis. This is for 925 hectopascal streamline analysis for West and North Africa. This is the map for West and North Africa, of course enhanced. It was cropped from the earlier Africa and Europe map, and is analyzed streamline. And this is to guide us on how to analyze streamlines, even over here, this area. Now, to remind us again, streamlines are lines drawn parallel or tangential to the instantaneous wind velocity. And the winds are winds. Winds over all the stations are winds taken at an instant in time, and that instant is 1200 GMT. Now, looking at the stations, we see here we are involved mainly with the direction. We are not looking at the geopotential height. We are not looking at the values of the wind, but the wind direction only. So, looking at this right-hand corner, we see winds here. This wind is a southerly wind. This is also nearly a southerly wind. And here is like almost it's a east of northeast wind. So we take this line southerly, going up, northwards, turning slightly, and then over here, because of the wind up over there, that is already almost like a westerly wind, so we turn around. And here we respect this, we turn to the turning must be almost like from an easterly, and then stops there. So this, since this turning is a clockwise turning, so this is an anticyclone. Then starting from here, we follow it parallel to this wind and goes down like that. And over here, of course, we turn around respecting this. This one we turn around respecting this. And then here we go northward because of this. Over here, we follow the same pattern like that, following the direction of the wind, and like that over there. And we put the arrows showing the direction of the flow. Likewise, over here, we follow this way and then end there. And there, the same thing. And we end there. Then coming to this area, we now draw lines respecting the direction of the flow, the direction of the wind. This is this way and that way. And over here, there's wind in this direction. So we draw, this is the wind. Of course, that direction shows we have to draw in parallel to that. So this is an asymptote of divergence. And likewise over here, the wind is in that direction, going towards from around south of southeast to north of northwest. We take that direction, and then this one, because there's a wind this way, we turn it around. So this is another asymptote of divergence. While over here is asymptote of convergence. Over here, asymptote of convergence. So the winds flow into this way and that way, and then go out this way and that way. And that is a neutral point. And as it's flowing out this way, it turns around into an anti-clockwise fashion, like that, and then ends up here. So we see a C here showing a cyclone. Then this one continues this way and joins here as an asymptote of convergence. The same thing with this, as an asymptote of convergence. Now coming to this side, we take this one parallel to this and go round because of this wind here, going almost southeasterly wind towards northwest. And then here again, the same thing. Since the turning is clockwise, eventually this area is the anticyclone. We take another one from here, going this way because of this wind here. We turn around. And over here, this wind is showing us a westerly, almost a westerly wind. So we have to turn around. So this one is now an asymptote of divergence. And as it gets here, we go down south straight, and over here we have to turn like that. And then over here there's a wind that is telling us there's a southerly wind. The wind must go northwards, this way and this way. So the winds here and here, they converge, leading to what we call asymptote of convergence. While the winds here diverge as a asymptote of divergence, over here it converges. Even this one that is going this way, because of this direction of the wind, eventually turns like that because of this, and then converges here as asymptote of a convergence. Likewise, all the stuff, they all converge here as asymptote of convergence. And then the flow here is in an anti-clockwise fashion, and then a C is put there as cyclone. This one, of course, is the neutral point, because the winds come in here, come in there, and then go out this way and that way. So this is a neutral point. And now this one goes up, of course, respecting this, and then because of this one, it goes north, continues north, and then joins with this, as we saw earlier. So this one again, because of this wind, we take it a line parallel, and it must be parallel to this one. We take it parallel. Then as we get to this point, we turn around because of this. We turn it around and then in this direction. And this flow pattern is a clockwise flow pattern, and therefore A is put there as anticyclone. So that is how this analysis is carried out. The analysis of streamlines for West and North Africa. So remember, we are concerned with the direction and not the geopotential height values, and neither the wind magnitude, but only the direction. And we draw lines parallel or tangential to the instantaneous wind. And this gives us the flow pattern over this map, the wind flow pattern. So I'm bringing this lecture again to an end. So we get to the next lecture that we now involve another upper level map, standard level of 850 hectopascal. That 850 is also a standard level. There are other standard levels. After 850, you get to 700, 500, and so forth. But we get to first to 850 in the next lecture. And so at this juncture, I bring this lecture to an end. And we'll meet again at the next lecture. Thank you very much, and God bless.